Hello. Today we're going to talk about 7.6 natural logarithms. All right, a natural logarithm is similar to a common log, okay? Meaning that the base is always the same. And in this case, the base is the number e. Okay, and I know that sounds really weird. All right, but e is now a number. It is never a variable in math. It is now this number. Just like pi, it repeats, or it doesn't repeat. It goes on and on forever. Yeah, so roughly 2.71, right? Now, how we write it, you could put log base e of x if you'd like, but it's more often written as ln of x. I don't know why they didn't put it as nl. I guess follow the log format. I don't know. They just write ln of x, okay? All right. Here's some, little fun fact right here. It is as you plug in number n, right? As long as n gets larger and larger, so you plug in 1, 2, 3, 4, 5, right? You keep going on and on forever, you're going to have a limit of this number. Okay, that's where it comes from. It's kind of like a cool little fact. All right, so let's solve some problems with natural logs. So in the first example, just like before, if we have natural log, we just set it equal to x, and then we solve. Okay, now you can think of this as log base e, so I'm replacing this ln with log base e. Then what's written there goes in parentheses. Then I do my loop-de-loop, okay, and we get e to the x equals 1 over e squared. Well, that's simple. E to the x is equal to e to the negative 2, right? Negative exponents move it to the bottom. So x equals negative 2. Okay. Problem number 2, set it equal to x. Again, replace this ln with log base e to the negative 4 equals x. I don't know what it is about having that e there, but it throws people off. Okay, so rewrite it with that log base e. I think that'll help. Then do your loop-de-loop. We get e to the x. Hold on, got to keep the color the same. It's going to drive me crazy. All right, we get x equals negative 4. All right, let's do another problem. Set it equal to x. So we get the log, so natural log of 1 equals x. So e to what power equals 1, right? Follow that loop-de-loop. And, well, e to the 0 power is 1. Anything to the 0 power is 1. So your answer is 0. Okay? All right, so what about combining logs? Same thing. These are all log base e, so we can combine them by with the same rules. So first move that as an exponent, so we get natural log of 25. Okay, then we combine these, we get natural log of 100. All right, I don't like this. I want it as a log, so I'm just going to put natural log of e, right? Remember, log base e of e, when the base and the argument are the same, it's always 1. So by writing this, I'm essentially multiplying it by 1. Okay? So then we can move the exponent. So it becomes e cubed. So now we get natural log of 100 divided by e cubed. And here's your answer. Okay? So when you see a number by itself and you need it to be a log, multiply it by a log of the base, and the argument has to be the same, whatever base you wanted. Okay. Problem number 5. do it one step at a time. I find that helps. So 5 minus 4, so we do 5 divided by 4. Now we can multiply. So times 12. Think of that as 12 over 1. So you simplify, you end up as natural log of 15. And those are gross numbers. Those are not nice. Those do not simplify. So just leave them like that. That's your exact answer. Unless I say round, don't put it in your calculator. Okay, so now let's do some solving. Same as before. We have it written as log base e of 3x plus 4. So log equals a number. So simply solve it just like before. Do your loop-de-loop. And now get the x by itself. We want to subtract the 4. And then we want to divide by 3. Okay? Number 7. We get natural log of x over 5 equals negative 1. Again, writing it as log base e really helps a lot of my students. Okay, we do our loop-de-loop. E to the negative 1 equals x over 5. We multiply, we get 5 times e to the negative 1. Now, I would accept this as an answer, but a lot of proper notation would say you can't have negative exponents. So technically, 5 over e is the proper way to write it. Okay, whenever you have a negative exponent, it flips, either goes to the numerator to the denominator, or from denominator to the numerator. All right, let's do another problem. So again, make sure you're rewriting that as log base e. And the part that's already written, okay, goes in your argument. So now when you do your loop-de-loop, all right, now we can just cut off the bases. Those e's don't matter. So 17 equals x plus 5. And this is wonderful because I get a nice simple answer. Okay, a nice real whole number. Okay, so don't be alarmed if you get some weird decimals, like weird logs or e's in it. Okay, 12 also works. Or whole numbers sometimes happen. All right, now to go the other direction. So here we have a power. We can't write 27 as e to the something. So we take the log of both sides. So log of e to the 3x equals log 27. Right? Hopefully you remember this. Right? We just did that lesson. So you get 3x log e equals log 27. Here's the nice thing though. What if we didn't do log base 10? Since we already have a e here, what if we did the natural log? If we did the natural log, well, look at that. Remember what log base e of e is? That's 1. This goes away. So really we have 3x equals the natural log of 27. And now we can do the natural log of 27 divided by 3. There's your calculator ready form. Let's plug it into the calculator. So instead of using log, we use ln. That's what this button is. So natural log of 27 divided by 3. Don't forget your parentheses. All right, if we're doing 3 decimal places, that would be 1.099. Okay, calculator ready form, decimal form. Okay. All right, let's do the last problem here. So before I take the log of both, though, I need to move the 4. So actually I get e to the 3x minus 1 equals 5/4. Then I'm going to take the natural log. So natural log of e equals the natural log of 5/4. Natural log of e goes away. I'm going to add 1. And then I'm going to divide by 3. And I'm perfectly fine with you writing it like this. Okay, you don't have to worry about simplifying it, getting into 1 natural log. I'm not stretching or pushing all that. Okay, so let's see. Natural log of 5 divided by 4. It's the first thing we did. Then we added 1 to it. Then we divided by 3. So notice I didn't try to write it as one big thing. I didn't have to worry about parentheses. I did it one step at a time, just like we did on the right-hand side. So rounded to 3 decimal places, that's 0.408. Okay, this is your exact answer. All right, if you have any questions, come see me in class.